All right, so what today's lesson is covering. So 12.3, as a reminder as well, today and tomorrow we're covering 12.3. Wednesday's just review of 12.1 through 12.3. Thursday's the summative quiz on 12.1 through 12.3. And then we'll be moving on starting on Friday, except for seniors that are in here, you'd start to review for your final Friday. But in lesson 12.1, 12.1A, when we found for different angle measures what sine, cosine, tangent, cosecant, secant, cotangent were for those angle measures using SOHCAHTOA, all of those angles were acute angles, less than 90 degrees, but still greater than 0. They were positive. As we kind of build here, what we're able to do today is find the values of the trig functions for general angles. So we can also find those values for angles that would be greater than 90 degrees or less than 0, so negative angles as well. And we can do this by setting up a right triangle on the coordinate plane. So I do want to stress here, for some problems you will actually need this. I would argue for example 1, what is written here does not have to be memorized. So for example, sine of theta is y over r. Do you have to memorize that? No. So I'm going to go through example 1, not even referencing this part, just using what we covered in 12.1. For something like example 2, you'll see how that's different from example 1. We will refer back to these. In general, for this class, this year, right now, if you need these on the quiz for something like example 2, I would give them to you. I'm not having you memorize these this year. You may need these in trig next year, in which case you may be required to memorize them next year when you are actually in trig, if you are taking trig. But what this is showing, so if you have any angle in standard position, and they're using theta, that Greek letter theta, to represent the angle in standard position, they're letting some point P with coordinates x, y be a point on the terminal side. So if this is where P is, you're drawing the terminal side of that angle through P, so that creates your angle theta here. Then what you can do is you can draw in the vertical side of a right triangle, and that vertical side should always be drawn from the point to the x-axis, wherever that would be. So you're never drawing a right triangle to the y-axis. It should always be to the x-axis. And then I'm creating this right triangle, and as long as I have a right triangle, I can use the 6 trig functions or find the values of the 6 trig functions of that right triangle. So you would have this side here. The length of that side would be the length from the origin to whatever that x-coordinate, so that length would be the distance of whatever your x-coordinate is. And then this vertical length is from the x-axis down to that point. That is the distance of whatever your y-coordinate is. And then they're calling the terminal side, the length from the origin to that point, they're calling that r. They're kind of building, eventually this would be the radius if there was a circle that went around through that point. That's in, I guess if you want to think of it that way, that's why they're using r, kind of looking forward to what that r would actually mean. It's meaning the radius. But then you would already have your x and your y from your coordinates, so you would already know those two legs. You would then just need to use Pythagorean theorem to find r, so that this is just the Pythagorean theorem rearranged using x, y, and r. And then that's how they're getting these 6 trig functions. So these are not anything different than what we covered in 12.1. If you think of, I know this is your whole angle theta, so if you kind of think of it as being here, we're going to learn eventually what this is called. This would be a reference angle to the entire angle theta. But you can see that y is your opposite side, x is your adjacent side, and then r would be your hypotenuse. So sine is opposite over hypotenuse, and that's why they have it here as y over r. You can see where that's coming from. Cosine is adjacent over hypotenuse, x over r. Tangent is opposite over adjacent, y over x, as long as x isn't 0. And then we have cosecant reciprocal of sine, secant reciprocal of cosine, cotangent reciprocal of tangent. Okay, so they are listing these in terms of y, x, and r, but they're not anything different than we covered in 12.1. So don't look at it as something additional you have to memorize, as long as you're just applying what you already know. So we're going to go through example 1, and like I said, in example 1, I'm not even going to reference these formulas because you don't really need them for what example 1 is asking. It says the terminal side of some angle theta in standard position contains the point at negative 6, 2. Find the exact values of the 6 trig functions of angle theta. Okay, so I'm going to make a sketch. And I'm going to plot where the point negative 6, 2 would be. So it would be in that second quadrant about there. And that point is on the terminal side of angle theta. So from the origin through that point, I'm going to draw in the terminal side of the angle. And that makes, from here to here, this is really what my angle theta is. And as I said from this drawing up here, you always want to sketch in, you want to create the right triangle by going from your point that's on your terminal side to wherever the x-axis is. Don't go over to the y-axis. Your triangle should have one of its legs on the x-axis. So I can draw like this side down here. So this is my right triangle. And we'd be going off of this angle here. Again, I know we haven't talked about reference angles yet, but we're going off of this angle here that's corresponding to angle theta. So we are finding the 6 trig functions for angle theta using this right triangle. And then I can label the sides that I have. So I know if this is the ordered pair, negative 6, 2, then the length of the leg on the x-axis is the distance from 0 to negative 6. So even though that distance is positive, because I'm going to the left, I'm going to label it as negative 6 because I'm going back 6. What that's going to mean is any of my 6 trig functions that use the side here, they're going to have a negative value. So some of your trig values will be negative, some will be positive. And then this side here is the distance from the x-axis up to my point. That would be the distance of the y-coordinate, which was positive 2. So I'll put a positive 2 there because I was going up, so keeping that positive. And then before I find the values of the 6 trig functions, I need to find what the length of the hypotenuse would be. Okay, so again, I know they're giving you this formula here. You're free to use that. It's just the Pythagorean theorem. So to find this missing side, I can use a squared plus b squared equals c squared. I don't have to use something different or memorize something different in terms of x, y, and r. It's just Pythagorean theorem. I have the 2 legs. I'm trying to find the hypotenuse. So it doesn't matter which one of these I call a and b. So I have 2 squared, which is 4, plus negative 6 squared is 36. That equals c squared. I know 4 plus 36 is 40. Is c squared, and then to find c, if I take the square root, I would have c is the square root of 40. Can I simplify the square root of 40? I know 40 isn't a perfect square, Theo. You can take out a 4. I can split it into square root of 4 and square root of 10, and I know the square root of 4 is 2. So therefore, c would be 2 square root 10. So all answers should be simplified. All fractions should be simplified. All radicals should be simplified. So if you can simplify a radical, I don't think any of the examples we've gone through together have been able to have a simplified radical, but this one does. So that's my hypotenuse here, 2 square root 10. And then I can label my opposite and adjacent. So from my angle here, the 2 would be the opposite, the -6 would be the adjacent. Okay, and I have all the information I need then to find the 6 trig functions. So I'm going to start with sine of theta. I know sine is opposite over hypotenuse, so that would be 2 over 2 square root 10. But then I have to simplify that. Now here the 2's would cancel out, so I would just have a 1 on top. I could also write a 1 in front of the square root of 10. I don't need to. And then how do we get the square root out of the denominator? Yes, multiply numerator and denominator by the square root of 10. So on top, 1 times square root of 10, I'll just have square root of 10. On the bottom, square root of 10 times the square root of 10 is just 10. It's the square root of 100, which is just 10. So square root cancels out. So sine of theta is square root of 10 over 10. Cosine of theta is, cosine is adjacent over hypotenuse, so that would be, now again, that adjacent side, that's why I put the negative there, because cosine here will be negative. So it's -6 over 2 square root 10. So then, again, I have to simplify. I can simplify the 6 and the 2. So the 2 is gone. 6 divided by 2 means I would have a -3 on the top. But then I have to multiply top and bottom by the square root of 10. So cosine of theta will be -3 square root 10 over 10. And then tangent of theta is opposite over adjacent. So that would be 2 over -6. So no radicals, but I still need to make sure that's simplified. And because that denominator is negative, that just means the fraction itself is negative. So tangent is also negative here. So that would be -1/3. Okay, and then I just have to find the reciprocals. So cosecant of theta is the reciprocal of sine. And I would want to go back to before I rationalize the denominator, when I had 1 over the square root of 10, and take the reciprocal of that. And that way I don't have to rationalize the denominator again. So if I take the reciprocal of 1 over square root of 10, cosecant of theta is just the square root of 10. It'd be the square root of 10 over 1, so square root of 10. Reciprocal of cosine of theta is secant of theta. And if I go back to the beginning here, after I simplified the 6 and the 2, I had -3 over the square root of 10. So that would be negative square root of 10 over 3. And then reciprocal of tangent is cotangent of theta. And that would be the reciprocal of -1/3, which would just be -3 over 1 or -3. So these would be the values of the 6 trig functions. On your homework quiz and on your summative quiz and on your test, whenever you have to find the values of the 6 trig functions, I do have the actual trig functions written out. You just have to then fill in the values of them. So that way you're not forgetting, like, okay, I have sine, cosine, tangent, cosecant, secant. Shoot, what's the 6th one? I have those written out. You just have to find them. And that applies to your homework quiz today as well. So any questions on example 1? So plot the point that you're given on the coordinate plane. Draw in your right triangle. Label your two sides. Find your hypotenuse. Once all of that is set up, then you're just doing what we did in 12.1. But I know setting it up can be challenging. That's kind of the new part here. Make sure you're practicing that. Otherwise, when it comes to the quiz Thursday, that might be a challenge. Practice it so you can ask questions before then. Okay, so then the second example, like I said, in the second example we're going to do, I am going to reference these, and you'll see why. You'll see how it's different from this. So in the second example, as we get to that, it says, if the terminal side of angle theta in standard position lies on the x or y axis, the angle is called a quadrantal angle. So there are four quadrantal angles, but then you could find coterminal angles to them as well. So if you have an angle of 0 degrees, which would also be 0 radians, that means your terminal side is the same as the initial side. This would be your angle. And so it would go through some point. They have coordinates. You'd have some x coordinate, but the y coordinate would be 0. We're going to look at how you would find the 6 trig functions to an angle of 0 degrees or 0 radians. If you have an angle of 90 degrees, which in radians is pi over 2, so that would be if you're given a point where the x coordinate is 0, but you have a positive y coordinate. So your terminal side would be on that 90 degree mark, which is pi over 2 radians. We'll look at how to find the 6 trig functions for that. If you have an angle of 180, so your terminal and initial sides just create a straight line. So this would be your angle theta here. You'd have a point that your terminal side goes through a negative x coordinate, y coordinate is 0. And then if you have an angle of 270, which would be 3 pi over 2 radians, that's when your terminal side would go through a coordinate with an x coordinate of 0, y coordinate that's negative. So one thing I want you to notice for the quadrantal angles, it is not possible for you to draw a right triangle in, like we were able to for example 1. So to be able to draw in a right triangle, your point has to actually be in one of the 4 quadrants, so you can draw a line straight either up or down from your point to the x-axis, and that is not possible when your point is actually on the x or y axis to draw a right triangle in the way that you should. So these we have to work through a little differently. That's why I said I will reference these formulas when we do example 2. So for example 2, it says the terminal side of theta in standard position contains the point at -2, 0. Find the values of the 6 trig functions of theta. I'm going to start it the same way. Draw where that point would be. -2, 0 would be here. So this is our angle, rather this would be our angle theta. So the problem doesn't itself ask for this, but what angle is theta? 180. 180 degrees, or that would just be pi radians. The problem doesn't ask that. You don't have to give that when you're answering these types of questions, but it's good to kind of make that connection of what angle you're finding the trig values of, because that really means we are finding the trig values of 180 degrees or pi radians. So any point you have over here on if this is your terminal side on that negative x-axis, all of those trig values should be the same because they're for the same angle measure. So here we're finding sine, cosine, tangent, and so on of 180 degrees. So to find these, like I said, I'm referencing the formulas on the front. I have my x and my y coordinates. And really here, if you found, you would still need r. So that Pythagorean theorem, in terms of x, y, and r, would be x squared plus y squared equals r squared. R is always thought of as the hypotenuse of your right triangle if you had one. It's the radius if you actually drew a circle through your point. So I could find r by squaring both my x and my y coordinates, adding them together, taking the square root. That's where this formula is coming from. So again, just the Pythagorean theorem. So my r would be x squared is negative 2 squared, so that's 4, plus y squared is 0. So r squared is just 4, meaning r is 2. R would be positive 2. Okay, so we have our x, our y, and the r. So r is basically the distance from the origin to that point, but we're actually keeping it positive. The x coordinate is what's negative. So if we were to find sine of theta, and on the front side, sine of theta has the formula y over r, the y coordinate over the radius r. So this is an example where we need these. Our y coordinate is 0, r is 2, 0 divided by anything as long as your denominator is not also 0, that is just 0. Okay, so I want you to make this connection. That means if your angle is 180 degrees, sine of 180 degrees is 0. That's what this is telling us. If you typed sine of 180 into your calculator, you would get 0. Cosine of theta is x over r. The x coordinate is negative 2. R is positive 2, so cosine of theta simplified is negative 1. So cosine of 180 degrees is always negative 1. Tangent of theta is y over x. So that would be 0 over negative 2, which is just 0. Okay, then I can find their reciprocals. So reciprocal of sine is cosecant of theta. Now I'm going to go back to not my final answer, but when I had 0 over 2. So cosecant would be 2 over 0. What happens when you have 0 in the denominator? It's undefined. Yes, you can't divide by 0. So cosecant of theta is undefined. It doesn't exist. So if you tried to find cosecant of 180 degrees in your calculator, you would get an error. And then cosine of theta, reciprocal is secant of theta. So that reciprocal, you could just go off of the reciprocal of negative 1 or go back to negative 2 over 2. That would be 2 over negative 2. If you flipped it, it's still negative 1. And then reciprocal of tangent is cotangent of theta. Similar to sine and cosecant, here I would have negative 2 over 0, which is undefined. So cosecant and cotangent of 180 degrees are both undefined. Okay, so if you think of these as kind of we're building to what we're going to be doing later, here you know what the values of the 6 trig functions are for 180 degrees. We'll be referencing that later on. But you would need those formulas that are on the front for that type of question, not necessarily for number 1.